Hello everyone, I am Muhammad Asif. We are going to start GCE O level chemistry 5070. In this video I will discuss experimental chemistry and focus on experimental design. In case of experimental design, we will discuss the different quantities used in the experiments and the apparatus involved. Those quantities are: number 1, mass; second, time; third, temperature; and fourth one is mass, time, temperature and volume. Now, the mass, SI unit for mass is kg, kilogram. The SI unit for time is second, small s. Small s is not capital because capital S represents sulfur symbol. Similarly, the temperature, the SI unit of temperature is Kelvin, represented as K. This is derived unit, that's why no degree sign is used in this case. But an ambiguity is there. The symbol used for Kelvin and symbol used for potassium is same. That should not be. And finally, the volume. The SI unit for volume is meter cube, because the SI unit for length is meter, and according to the formula of volume is length into breadth into height. If we use 3 times the same unit, meter multiplied by meter, we will get answer meter cube. That's why the SI unit for the volume is meter cube. But normally in chemistry we use decimeter instead of meter. Now we are going to discuss some multiples and sub-multiples of all these units which we use in chemistry measurements. For example, 1 kg is equal to 1000 grams. 1 kilogram contains 1000 gram, and 1 gram is equal to 1000 milligrams. Milli means thousandth part of a gram. Now, in this way, we can use all these base values for the interconversion. If milligrams are given, we can convert them into gram, and if grams are given, then we can convert them into kilogram, and kilogram into gram, vice versa, same. Similarly, the time, actually the definition of time is the occurrence or events taking place, interval between 2 occurrences is called as time. The SI unit is second, and multiple and sub-multiples are measured. For example, seconds, normally stopwatch can measure milliseconds also. Stopwatch can measure milliseconds, but multiples are, we know that 60 seconds is equal to 1 minute, and 60 minutes is equal to 1 hour, and 24 hours is equal to 1 solar day. We know all these values, and using all these base values we can convert all of these into one and other for the calculation of times. Now next is temperature. The unit of temperature is Kelvin. There are two other temperature units are used. Those are centigrade and Fahrenheit. Both of these are measured directly from thermometer. That's why degree sign is used for both of these temperatures. But the Kelvin temperature is derived from the centigrade. We know the formula. Kelvin is equal to degree centigrade plus 273. This is the formula which is used to convert degree centigrade into Kelvin. And there is another formula which is used to convert Fahrenheit first into centigrade, and then centigrade can be converted into Kelvin. That is quite easy. In this lecture we will just assume the interconversion of both of these Kelvin and degree centigrade, because the Fahrenheit is not involved. Fahrenheit is basically used when body temperature or very sensitive measurements is required. Next is volume. Now volume, as I have already told you that SI unit of volume is meter cube, but this is a larger unit. This is a bigger unit. Now this unit can be converted into smaller one. We know that 1 meter cube is equal to 1000 dm cube, decimeter cube. Deci mean 10th part, decimeter cube. 1 meter cube contains 1000 dm cube. Similarly, 1 dm cube contains 1000 cm cube. Now 1 centimeter cube is also equal to 1 centimeter cube is equal to also 1 ml, 1 milliliter. Now this 1 dm cube is also called 1 liter. Means that if 1 dm cube contains 1000 cm cube, and if 1 cm cube is equal to 1 milliliter, then automatically 1 dm cube contains 1000 milliliter. All of these values should be well prepared by the students, because whenever we go for the experimental chemistry, sometimes the volume is given in centimeter cube and sometimes it is given in decimeter cube. For majority of the calculation which involves concentration, we use the solution in decimeter cube. If centimeter cube is given, then we have to convert into decimeter cube, and then we use all these values in the experimental chemistry. Now these are the values. What are the different apparatuses used for the measurement of all these? We can discuss all. For example, if I explain all of these, mass is measured by spring balance and fan balance. Both can be used. Spring balance or beam balance can also be used, and digital balance are also used for these purposes. Time is measured using stopwatch. We have already know about the stopwatch. Now stopwatch are installed in all the mobile system. We have all watches. We can use all those for the measurement of the time. Next is temperature. The temperature is measured by glass thermometer. The glass thermometers are of two types normally available in the market. One is called as a mercury thermometer and second is alcohol thermometer. Alcohol is also used instead of mercury, which on expansion can show the temperature of a certain area. Now, as the degree centigrade is not directly proportional to so many parameters, that's why we have converted degree centigrade into Kelvin, which is exactly directly proportional to with the behavior of gases. That's why we consider Kelvin as the most important and accurate unit instead of degree centigrade. That's why we use Kelvin, not degree centigrade in our calculations. Not in our calculations. Next is volume. For the measurement of volume we use normally the volume may be of liquid and of gases and of solids. If we have to measure the volume of solid, either it is a regular or irregular, we know that we can use a cylinder, put liquid into the cylinder and note the volume of the liquid. Then put solid into it and then find the final volume. The difference in volume will be the volume of the solids. But in case of measurement of liquid, we use so many different types of apparatus. We use pipette. We use pipette with pipette filler to avoid any inconvenience for the safety purposes. We use burettes. We use cylinder. We use conical flask. We use measuring flasks. There are so many apparatuses which are used for the measurement of the volume of the liquids. For the measurement of volume of gases, we use gas syringe. We use gas syringe. Now, gas syringe is entirely different from the hydraulic syringe. Hydraulic syringe is very hard. It is difficult to measure the gas with help of hydraulic syringe, which is used for the injection purposes. The volume of the gas can easily be measured using a gas syringe. Gas syringe is a glass syringe which is frictionless and easily movable. That's why a slight change in the gas volume can be measured accurately. These are the basic units, their measurements, and the apparatus involved for all these values. Now, all these multiples and multiples of these quantities should be quite clear in the student's mind, so as we can use all these in calculating the different values obtained in experiments. Now, these experimental design comprises that if we want to perform some experiment, then we should know which quantity we have to measure and how we have to arrange whole of the apparatus in accordance with each other to get a maximum accurate results. I hope from this lecture all the students become quite aware about the properties and all those quantities which have to be measured in experimental chemistry for the experimental design and all interconversion units with one another. This is all about for this lecture. Thank you.